Okay, today we're going to be learning about Creo Parametric. It's a very powerful software. I've used it for 10 years. I've used SolidWorks for 2, CATIA for 2, and I have to say Creo is my favorite. So let's start by maximizing the window. Closing this window here, that's pretty much your basic startup, is maximize and close that. The first thing you want to do is set a working directory. Now, ProE works a little differently than most softwares. Most softwares, the file path is the file path. But in Creo, what will happen is when you have, like, say, an assembly, and you have multiple parts inside of it, and the assembly is in this folder you're working from. Whenever you set your working directory to that folder and open that assembly, it's going to look for those parts inside that folder. If they're not inside that folder, it'll fail and ask you to find them. So you want to go ahead and put all your parts you're working with for this particular job all in one folder, and you want to use this working directory as a final directory. It works well for common components and stuff like that, so you're not polluting your components with changes and things of that nature. But anyways, so click your computer, your C drive, create a folder here. Mine's called ProE. You can right click, create folder. Mine's called ProE. Then right click, create a folder, new folder, call it Creo Training. Double click on it. Right click, create a folder called Lesson 1. Double click on it. And then once there's a period down here and you're directed towards that folder, you're good. Now if I create another folder in here, temp, don't do this, but if I create another folder, temp, it would automatically direct us into that folder. But if I'm back in the lesson folder and I click on it, it'll set the working directory to that folder. So you want to make sure you don't click on anything when you, well, don't hit that either. You don't want to click on anything inside the folder you want the working directory to be set in. Otherwise, it'll set it to that folder. So hit OK. Now we're ready to open a new part. It's up here at the top, new. You have a bunch of options. You can do a new sketch. You can save a sketch outside of a part, an assembly, a manufacturing, a drawing, a format for a drawing, and a notebook. Never really used the notebook. Then you have a solid, sheet metal, and bulk. Solid and sheet metal are the ones I've used the most. Let's go with solid for now and call this Lesson 1. It's important to note that Creo does not like spaces. So if you want to use a space, you need to use an underscore or a dash. I use the underscore most often. But you're welcome to use a dash. Run-on sentences get annoying, so please do use some sort of separating function. I hit OK. I'm going. You'll be created with a part that has the default datums in it. They are the right, left, and top plane, and then a coordinate system. These are where you'll be defining your sketch as references from. So everything will be based on these planes and this coordinate system, unless you create more planes and coordinate systems. The first thing we'll do is we'll create a sketch. Now this sketch is going to be disconnected from everything else, except for the reference planes that it's on. It's not going to be connected to an extrude or a revolve or anything like that. It'll be its own sketch. So we're going to click the top plane. You can see over here, if you watch when I hover over that plane, you can see it underlines which plane you're selecting. So select the top plane. And then in this, you see you can go back. Say I selected the wrong plane, I can click back in there and then click another plane to set that as the working plane, the sketch plane. And then it creates a reference plane to orient the sketch so that You know, like let's say you had another plane and you wanted to have it be the bottom of the sketch. You can come down here and select bottom and select that plane. But for right now, we're going to leave it as default and hit sketch. Now we're in the default view, and we have our reference lines, which are references of the planes that are 90 degrees to the sketch plane. Oh, first, uncheck spin center. When you rotate with spin center, it uses the center of the part, the center of the coordinate system. If you uncheck it, it uses the center of your cursor, wherever your cursor is when you hit the center mouse button. So that's useful if you have a part that was defined over here because it was defined in an assembly, and you want to rotate around it. You don't want it to rotate it like this and have it spinning all the way out here. You want to be able to rotate from the center of it by clicking in the center of it. So that brings us to rotations and movements. When you want to revolve around something and move around it like this, you hold your center mouse button down and then you move your mouse. And that's what spins the part. You can hold it in the center and rotate it from the center. You can hold it from the corner of this plane, rotate it from the corner of that plane. Anywhere you want, you can rotate it around that point. Next is shift. Shift center mouse button. Click and hold both shift and center mouse button, and you can drag your part around. This is useful if you have, say you're selecting the tops of a bunch of holes, and for a chamfer or something like that, you can click, 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 shift, drag, click, 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 shift, drag, and move along the part without zooming in and out. The other one is control center mouse button, hold, and that will zoom you in and out. Control, yes, control center mouse and control mouse move will rotate you about that point planar. So drag up, zoom in and out, drag to the side to rotate. And that's control center mouse button, hold. Now if you just want to zoom in and out, just roll the mouse wheel. Just roll the mouse wheel. Center mouse button, click and hold to rotate. Shift center mouse button to pan. Control up, or control over to rotate along a plane. Control up to zoom, or center mouse button roll to zoom. Okay, those are the basic command functions for moving around in Creo. Now, let's get to our sketch. So, you want to do most of your sketching view from the sketch plane. It makes it easier to see. Sometimes you'll need to rotate around to grab a reference or something like that. So you will want to be familiar with moving around and getting back to the sketch plane. So this button right here takes you back to the sketch plane, moves it there. This button up here, sketch view, does the same thing. So this button or this button. Now let's start with lines. So we're going to create a line. We're just going to create, we click that button, and then we click, let our mouse move around, click again to end the line. Then we click, click, and now we're at the end. We've created a closed circuit. We want to make that triangle an extrude. We want to make that triangle whatever. What we do then is hit the center mouse button once to end the line chain, twice to end the line function. So now we can change our dimensions and move everything around. Now, I'm going to use Control Z inside the sketch to undo what I've done. I've found that Creo doesn't really like undo. It may be different in version 8, but I've mainly used version 4. And undo is often unusable. So don't get too hopeful that undo is going to save you. But in this case it will, because I've tested it. But that's the thing. A lot of companies like to validate software for a couple of years. Creo 8 really hasn't been out to be long enough to be validated. So there's probably some hot fixes that'll come for it that'll fix some bugs that you may come across. But new releases are always like that. So now let's Control Z twice. And we'll go to rectangles. The first rectangle is a corner rectangle. So this one you click anywhere. Let your mouse button move, not drag. It's just click and move. Click again, and your rectangle is created. Now this creates one rectangle, and it's still ready to create another rectangle. So I could come in here, click, and create another rectangle. And you see right there, it's creating references when those lines turn green. So, or constraints. This two vertical lines are constrained by a vertical constraint, meaning they're in line with one another. These two green lines are equal to one another, so they're the same length. So you only have to do one length dimension to dimension both of those. So that's handy for doing a lot of different features, and you want them to be the same. It can default to that. If you don't want it to default that, before you click, hold Shift, then click. It will not have any references to any other parts. It will not have any constraints that match other parts. So then you can center mouse, and center mouse will close the function. So center mouse once ends the line tool, center mouse twice, or center mouse during rectangle will end the rectangle mode. So you're no longer creating any rectangle modes, and you're back to the select function. So we'll Control Z. The next rectangle on this drop-down menu is the slanted rectangle. This rectangle is useful if you want to, which I'll walk through how to create it. You click, draw a line. See, this is making a parallel line with that one. Click again and drag out to create your rectangle. When I say drag, I mean move your mouse. Don't click and hold. And click again to end the feature. Center mouse in the rectangle, and you're free to dimension it. This is useful if you have something where you need to make a block that's at an angle to another, but you still want it to be a square. I've used it a lot in my design days, not as much as the straight rectangle or the corner rectangle or the center rectangle, but I've used it a lot. Next is this center rectangle. That will create a rectangle with the center point. You see, I'm right now I'm going to determine the center point. So I'll click here on the center of the axis, and now I drag the rectangle away from that center point. You can see it snapping to other references there. This is useful for when you have dimensions from center, where a machine shop requires you to have all your dimensions from center. This way, this block is centered up on the XY datums, or it's centered up on a hole, or it's centered up on whatever it needs to be centered up on, but it's a centered up rectangle from that point. You can control the dimensions by double clicking on them, typing in a number, and hitting the center mouse to confirm value, center mouse, and that makes it, and then you're done. Once they turn to this purple color, that's the thing. These blue dimensions are automatically created dimensions that have not been given values by the user. When they turn to this purple color, it means that they have been given values and they are a user-created value. You can also go up here to the dimension slider here, and you can create a new dimension to there. And these new dimensions will override any blue dimensions that are on the screen. So there was an angle right here that was a blue dimension for constraining this without our interference. Now that we've interfered, we've added a dimension, it deleted that reference, that dimension, and so when I try to create one, it's saying it's overdefined. So we have too many references that determine the angle of this part. I have two options. I can delete one, or I can make one a reference dimension. A reference dimension is basically just like it's telling you that's what the value is, but it has no effect on the parametric constraints of the system. So like, for instance, that one's a reference dimension now. If I change this to 40 degrees, that changes to 50, and I can't edit it. It's not allowed because it's a reference dimension. So those are dimensions and rectangles. There is one more rectangle called the parallelogram. It's not that useful, but it's there. You click, draw a line, click, and then you can drag your parallelogram however you want it to be. Click one more time, and you've created your parallelogram. So, and then you're free to dimension it as you will. Angles and what have you. So now another way to delete all of these is to click, hold, drag, release, and that basically makes a selection window that you can select everything that's inside there. I held Control and selected my axes so they would not get deleted, and then I will just delete. See, those axes are still there. And if you want to select more than one thing, like for instance I have this, and I want to delete this line, this line, this line. What I will do is I will click one line, hold Control, click the next, then click the next. And then I can delete those without affecting the rest of them. So now I'll click, hold Control, click, hold Control, click, hold Control, click, and delete. So now circles. The center, what's it called? Center and point is probably the most useful circle. Kind of like the center rectangle. Click the center point, allow your mouse to move, and you can move out to create the diameter. Click again to create the circle. So click center point, drag your mouse without holding click, without holding the click, click again to complete the circle. Oop. Went too far. So the next circle is concentric, so we actually need one of those circles back. Again, we click the center point and drag, and then clicked again. So then we click on the circle or the arc, and then we can, oh, not the right one. Concentric, we click on the circle or the arc, and we drag outward, and it creates a concentric circle, or with the same center point to that circle. If you click, it allows you to do another. If you don't want to do another, center mouse button ends the feature. Center mouse button twice ends the feature, actually. So there you have two concentric circles. Now we have the 3-point arc. So if I want to create a circle that intersects this line, and there. So I clicked once, twice to create the points, third time to create the circle. Once, twice, third time to create the circle. That's kind of useful if you're if you've got a set of lines and you want to create your circle, and you can create a tangent to that one. So then you can come back in here and you can go to delete segment. See, delete segment, click and drag through the line you don't want, and it will delete it. So I can actually click delete segment, click and drag, and I can delete all this stuff. That's really useful for trimming sketches. Okay, so the last one is 3-point tangent. So we're just going to create some center lines. And that's right here. These are construction center lines, meaning they don't show up anywhere other than in the sketch. They are for construction only. And then you can go to circle and go to 3 tangent. Then you select the line you want it tangent to. How's it going to work for me? Will not work with references? Well, maybe it won't work with construction lines. It used to. No, it won't work with construction lines. So it has to be a line. But if you click on the one line, click on the one line, click on the second line, and then click on your third line, and it'll draw a circle with 3 tangent points, and those references will be there. Those constraints will be there. You can see them right there. That's a tangent constraint. Okay. So now we'll move on to arcs. There are 3-point arcs, which are probably the most useful. Point, point, let's click, click, and click. And this created a constraint to this axis here. So click, click, and click. Let's create arcs. Center and ends is kind of like the center tool on the circle. You click the center point, you drag out, you click to create one end, then you click to create the second end. So you have basically this circle only for this extent. So next we have tangent, which again we need some lines for. So we're going to go there, there. Well, it's going to need a third one. And you don't actually have to have a third one. You can just click. Well, I say that. Obviously, it's not one I use a lot. So click, click, and click. Click on line, click on line, click on line to create the tangent arc. And then the fourth type of arc is, again, concentric. So we're again clicking on the arc that we already have, letting our mouse go outward, clicking again to create the arc, and then it becomes like a center and ends arc, where you have the flexibility to put where the endpoints will be. Again, center mouse to get out of it. Conic. The Conic Arc is again one I don't use very often, but you click to establish the endpoints, much like the 3-point arc. And then you can drag the end point of the arc around to create kind of an ellipse. So click, and you've got your conic arc. Now ellipses are pretty simple. They're just endpoint. It gives you a line between them, endpoint, and you drag to create your ellipse. And when I say drag, as always, it does not mean hold left mouse and drag. It just means move your mouse. Next is the center and axis ellipse. So you define your center point. You draw your axis. We're going to go off at a crazy angle here. And then you create your ellipse. Centered about that point. But the ellipse, so it's basically the same thing as this ellipse, only you're given a center point to draw it off of. So you can do very similar things with the two ellipses, actually. Okay. Now the spline tool. The spline tool can be very powerful, but it's kind of hard to use. So you can just draw, click, 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 and you've created this weird shape that, well, maybe you need a weird shape. Kind of a more practical use of it would be to create two lines. And let's say you want to connect these two lines, but you don't want to use arcs and lines to do so. You can go in and use a spline and do that, and hit dimension. Well, how do I do it? Oh, it's tangent. Go to the tangent constraint, and it creates a nice smooth spline between those two. There's no straw.
I know, because there's no dolls left.
Get one out of the other box. Get one out of the other box and I'll open it for you. So again, that's the tangent constraint here. Can be used to make this spline tangent. Now, fillets. So let's just make a rectangle here. We'll do a corner rectangle. We'll delete this spline, and this spline, this spline. Now we can do a fillet, and we just select the first line and the second line, and it creates a round between those two lines. And you can do that as many times as you like, just by clicking first one line, then the second line. And you have to be careful with this, because if you have, let's say you have a rectangle outside. Let's say you have a rectangle outside of this. And if you accidentally click here to here, it'll create a fillet between those two and eliminate that. But it's a very powerful tool that can save you a lot of time in other creating rounds. Or, for instance, sometimes I get into sharp corner situations where if I don't have a round on my extrude, when it comes out, it'll bust through the part, and I don't want that. So I'll add fillets to my extrude to eliminate that. Next, there's a couple different options in fillet. There's circular trim, which is basically the same thing. It just doesn't create these witness lines here that can be used for dimensioning, or this endpoint here that can be used for dimensioning. Elliptical trim is just a little different shape, and it comes with different dimensioning rules. And elliptical trim is the same thing as circular trim. Now, chamfers, there's two different types, chamfer trim and chamfer. Chamfer trim trims those lines so they're not there. Chamfer is probably the one you're going to use the most. Click one line, click the next line, you've created a chamfer. Click one line, click the next line, you've created a chamfer. You can dimension these with angles, with heights, however you want to dimension them. I believe the standard is height and angle, or height and height. So now we'll skip text for now. That's more advanced. Offset. So offset is kind of cool. Let's just delete this stuff real quick. Hold Control, click, click, delete. So we're going to create a center rectangle here. Now I'm going to offset. Now it brings up this box over here. It says single, chain, or loop. So if I click single and I click one of these lines, it'll give me a direction line as to what way it's going to offset it. And then I can enter a value. Let's do 10. So now it offset at 10 inches from that location. Now, if I do chain, I'm then able to select this, click once, hold Control, click again. And it selects everything between those two selection points. And they have to be in a chain, they have to be connected for that to work. So then, I can hit next, or I can hit accept. Next will flip the direction of the connecting path. So like say this wasn't a rectangle, you know, if I had a pentagon and I wanted sides 2 and 3 and not sides 4 through 5, I could use next to pick which one I wanted. Then I hit accept. Again, it brings up the directional value, and then I can put in an amount. So let's give it 20. Now loop will offset. Again, you can select one line. It'll offset the entire loop that is in the direction shown, that is on that particular line. So that line is a part of. So I'm going to go with, since I want the offset to go the opposite direction, I'm going to use a negative value and use negative 50. And you can see that rectangle has been offset. Into the complete rectangle has been offset inside of the other rectangle. Now Thicken is an interesting tool. It will create, and we're going to go to loop and open. And we can click on this and we can give a thickness. So let's give a thickness of 100. offset value. So the thickness is how far these lines will be apart. The offset is how far they'll be from the one line will be from the first line. So we'll make that, since we made that 100, let's make it 50. Let's make it 25. Now it's created a line and an offset 75 in, because it's 25 out, 75 in for a total of 100. And that's what it's created. So I don't use thicken very much. Use offset quite a bit. Center lines. Center lines are great for doing symmetries, or for you know, for instance, let's say I want to draw a line, and I want to hit that line with each one of these going down. But that center line allows me to make sure that they all hit that without adding any more constraints. So it's a little easier way to do it. Center lines are also good for mirrors. For instance, I drew this line on this side of the line. I select it. I come up here. I hit mirror, and I select my center line again, and it creates the same line on the other side of the mirror, other side of the axis. Points. Points are good for placement. They're construction only. They won't show up throughout the sketch. These points over here will show up outside of the sketch. These axis lines over here will show up as axes inside your part if it's in a sketch. So you got to be kind of careful about these on your sketches, that you don't use these if you don't have to, or unless you really mean to. Palette is an interesting one. Takes a little bit to open, but it's got a bunch of default shapes. For instance, it's like a hexagon for a bolt, and you know, all these different shapes, these profiles. You know, like your I-beam profile, your C-frame profile, your L angle profile, your T profile, arc racetracks, crosses, ovals, racetrack, which is very useful for what we do. I'll show you on a later video. And stars, if you ever, for some reason, needed to draw a star. But that way you don't have to draw them. You just double click on them, and you click in the graphics window, and it'll place it there. You can do all this here, and rotation's a good one to do. So sometimes you want it at a 15-degree angle, 25-degree angle, I guess. It'll go ahead and angle it for you, and you can confirm it, and that angle will be there. And then you can redefine it as you want. Yep. Okay. So but we are going to references, and if you delete your axes on accident, click references up here at the top. I just clicked, and then select your planes. Here, I'll just redo it. References, plane 1, plane 2. You've got your axes back in the sketch. Hit this button to solve it, and close to close it out. Now we're going to just draw a rectangle. We're going to make it 10 by 20. Double click and center mouse or enter to confirm your dimensions. Okay. Now, there's other things in the sketch window. Delete segment, corner. Corner is useful if you have drawn some lines and you realized that this isn't closed. You made a mistake and there's a hole between your two lines. So you grab corner, you select the one line, you select the other line, and it will trim them together. Divide, you can separate lines at points. Useful if you're trying to. Another thing is, like, if you got center lines, I can actually delete segment and delete segment between center lines and axes, so I can trim that up. So these are constraints. Vertical is automatically given to anything on a rectangle that's vertical, or a line that's drawn vertical. You can either draw a line like this, or you can draw one with the vertical constraint already on it. If you wanted this to be vertical and it isn't, click vertical, click the line, it's now vertical. Now the important thing to note about this is it's not done. So if I have delete that automatic constraint. If I have 3 lines and I click vertical, I can hit all 3 lines without hitting another button. You have to hit center mouse to end that function, so you don't accidentally hit something vertical that you want it to be horizontal. The same thing works for horizontal lines. You have your line, horizontal. Perpendicular. You can set 2 lines to be perpendicular to one another. We'll use these over here. This to this needs to be perpendicular. Now there's a 90-degree angle between these without setting a 90-degree angle. Tangent. So if you have a circle or an arc, very common example would be having an arc like this, and I want that to be tangent to that line. Now it's tangent to that line. I can even set the other end to be tangent to that arc, or to that axis. So now I have a nice tangent arc there. Midpoint is useful for, well, for instance, I drew a line from there. I want that to be on the midpoint. That point be on the midpoint of that line. So I click the point, then I click the line, and that now snaps to the midpoint of that line. Coincident just makes, I select the endpoint and the endpoint, and that makes those 2 points coincident or with each other. Symmetric is mirror, like I showed you earlier. I can make this symmetric. Oh, it's not the same as mirror. It's if I have a point, for instance here, and I want to make it symmetric, I'll click it. I'll click this axis, and I'll click this point here, because for some reason I want that to be symmetric. Now this point and this are symmetric about this axis. So if this axis changes, or if one of these changes, the other one will change with it. Equal to, very useful. I can make this line, click equal, click the next line, click the next line. Again, this doesn't end until you hit the center mouse button. So don't accidentally make something equal to you don't mean to. Hit the center mouse button to end the feature. I think you have to hit it twice, actually. Yes, because hitting it once will leave the equal constraint active, so I can make something else equal, but it won't equal what I had the first equal to. So clicking it once just resets equal tool. Clicking it twice ends it. Parallel tool is what it says. Make this line parallel to this line, or this line. Or I can make this line parallel to this line, and it just makes them parallel. So I believe that covers most everything in sketching. There's more we'll cover later on another video, but for now that should do it. So we'll go out, we'll create a quick rectangle here, 10 and 20. Hit OK to confirm the sketch. now we have an option. We can either leave that sketch as it is, or we can use it in an extrude. Or if it was the right type of sketch, we could use it in a revolve. See, the revolve is just asking us for the axis of revolution. So we can use these sketches in features. However, Pro E has a good feature where if I click extrude first without going to a sketch, I can then define a sketch inside of the extrude. So that way I can come in here and I can go, okay, now I'm going to sketch a circle and make it 5 in diameter. Now, wait a minute. What if I decide I want to use that sketch? What if that sketch is like a skeleton? Can I use any of it in this sketch? I can by coming up here to project entities. I'm doing something, Brenna. Stop it. So I go here, project entities, and I am again left with single chain loop. And for this one, I'm going to use loop because I want the whole thing. I'm going to click it, and it projected that onto the sketch plane. If I had the sketch plane was 20 inches up, it would project it 20 inches up. So now I'm going to extrude a square with a circle through it. Again, that's project, single chain or loop, click, and you're good. You can do the same thing with offset. And if you come in here to your references, you'll see now that you have references to that sketch. You can see the curve 5 sketch, curve 5 sketch 1, curve 5 sketch 1, curve 5 sketch 1. So those stay in there. If I were to delete one of those, then it would lose its position and I'd have to reposition it with a dimension value. Okay. Oh. 10. Now that is just a, well, let me go back here. That is just a solid extrusion. So there's surfaces and solids. We're not going to talk about surfaces right now. We'll talk about them when I talk about surfaces in general. But for solids, then you have a depth value. This is a blind extrusion, or variable, they call it now. You can have symmetric, which means it's symmetric about the plane, the sketch plane. So it's 5 inches to either side since it's 10-inch extrusion. Or up to reference, which would mean that I could create a plane well, maybe. $20 inches up and extrude to that. That's useful if you're trying to fill a gap, or if you have a contoured surface that you want to extrude up to, or an angled surface you want to extrude up to and match. Not so useful for what we're doing right now, though. So we'll go back to 10 inches. And we will delete that plane. That's it. Whenever you've done something in your model tree you don't want, just come over here, click it, hit delete. Hit OK. Now if it's something's referenced to it, like the sketch we just referenced our extrude to, I hit delete, it'll show that it's going to delete that extrude. And we have options. We can suppress or suspend that extrusion and create it as a problem child or a feature with errors and not delete it. So that we can fix it, we could go back in and redefine that rectangle so that it's not constrained to that sketch and go on with our lives. We won't do that right now, but just wanted you to know it's aware. So we're going to cancel that. We're not going to delete it because it's going to delete our extrude. So the next thing you can do with extrude is you can do cuts or remove material. So we're going to define a sketch inside the extrude on this face. You're going to click this face and confirm your sketch with the center mouse button. That's the thing. Most things can be confirmed with a center mouse button in Creo. Use your center mouse button. So we're going to blow a rectangular hole through this, because we can blow another hole another way. So 3, 3, 5. So there we go. And we'll throw a fillet on there for fun. Fillet, line, 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 line. And we want those to all be equal to each other, so we'll grab the equal to constraint. Oh, wait a minute. We're going to undo that. One thing to look out for is it defaults to the last one you used. So I used the elliptical fillet last time, so you want to make sure you switch back to your circular fillet. Okay, now hit the constraints and equal. Then just click them. Center mouse. Double click on the dimension. Set it to 0.25. Now we're again left with a depth. But you have some more options this time. You can go symmetric, which wouldn't do us a whole lot of good because we're on the outside of a block, but maybe it would. You can go to through to next, which is switch it to remove material so we can see what that does. That goes all the way through because there's nothing. And then there's through all, which actually should go through all. Through to next should not go through all. But I guess because this is slightly bigger than this hole, it's gonna go through all. And then through until, I can make it go through until, which again isn't working out quite right. And through to reference, which means I can select a plane. Like if you're extruding up to a angled or a complex surface, you can go ahead and extrude up to that surface. We're just going to do through all for now. Through all is a pretty basic one, a pretty common one. Through all and the blind or variable are probably the most common ones that I use, along with symmetric. Or remove material. There is something called Thicken sketch, which basically creates an offset from your sketch to create that extrusion. Useful if you're creating like a box or something like that, but not as useful for most things. You have options. You can actually define a second side. So this is through all in the one direction. If I was on the center plane, let's change that real quick. Edit, sketch setup, sketch, plane. I selected that other plane, and now my sketch is on the center plane of the part. So we're going to confirm that. We're going to get out of our sketch. Now my through all only goes in one direction. So what do? I go to options, I go to side 2, and I go to through all. And now it goes through both ways. Alternatively, I could have made that a symmetric and gave it a dimension, but if I changed the dimensions of this block, it may not have worked. So through all is really the best in this situation. So now we're going to confirm this. And that is the basics of sketches, extrudes, and moving around in Creo. Next up will be revolves and sweeps, and then we'll start going into holes and the engineering functions.